Welcome back to Computer Graphics Laboratory with the mini project, that is 17 CSL68. Today we are going to discuss program number 6. That is, to draw a simple shaded scene consisting of a teapot on a table. Define suitably the position and properties of the light source along with the properties of the surface of the solid object used in this scene. Means here in this experiment we are practicing theoretical concepts whatever we have discussed in illumination and lighting model. Whatever theoretical concept we have discussed in illumination, lighting model, those concepts we are implementing here. Then we are seeing the effect of illumination and lighting and the property of the solid object, then how to set light, how to set the property of objects when you are drawing any real object in OpenGL. Right? Before going to program, just I will refresh the theoretical concept, whatever theoretical concepts we have discussed in illumination model and lighting. Right? Illumination models and rendering. That means a drawing. Illumination model is rendering. Right? An illumination model is used to calculate the intensity of the light that is reflected at a given point on a surface. Again, illumination model, shading model, lighting model. Again, there are many names for illumination model. In some of the textbooks they may call illumination model, lighting model, shading model. What do you mean by illumination model? When any object is visible to our eye, that visibility is nothing but the rays reflected from that object. Whatever rays enters into your eye, that is a reflection. Means only objects are visible if some light falls on that, then that light reflects into your eye. That is called illumination. To do this, we have to calculate the intensity of light. To calculate the intensity of light fallen on that object and reflected light. Means actually we are calculating reflected light intensity. Whatever is reflected, depending on that, we will say that it is a shiny surface, that is this color, that is that color, all those things. Right? To calculate the intensity of that light, whatever light has reflected and whatever light has entered into your eye after falling on the object, that is called illumination model. To calculate that intensity, we have different illumination models. In OpenGL and computer graphics. Right? Again, what is the rendering? The rendering method uses intensity calculations from the illumination model to determine the light intensity at all pixels in their images. So we have to calculate the intensity of the light, then that intensity we have to use whenever we are drawing any object on the monitor. Right? Because every pixel may be having different intensity, or there may be many pixels may be having same intensity. Right? That's why we have to on every pixel we have to calculate the intensity of the light. Then with that intensity I have to illuminate that pixel on my monitor. Then only you will feel that yes, that side is blurred, this side is dark, all those things. Right? That is what rendering. Right? One example you can see, there is a sunlight falling on the pyramid and one surface, reflected surface, that is a cube, right? Cylinder-like structure. Then that there again some rays falls on some other object, then that object will reflect, again that reflected light falls on other object, then that ray may be entering into your eye. Then what is the intensity of that light, which light has entered into your eye, and that particular pixel you have to calculate. And that particular dot, one ray or many rays might have entered into your eye, then what is the intensity of that entered light in your eye, that you have to calculate. How that has arrived, whether that has directly came from this light source or that came from the reflecting from other object, that we have to calculate. Means depending on that, we have to calculate the intensity of those entered light rays. Right? Then here illumination model parameters means whenever you are calculating the illumination model, means whenever you are discussing illumination model, all illumination models have different parameters. Right? Lighting effects are described. Again, as I told, illumination model, shading model, lighting model, all are same. Right? Lighting effects are described with models that consider the interaction of light source with object surface. Right? The lighting effects are described with models that consider the interaction of light source with object surface. Again, how light has fallen on that object, then the object surface also matters here. Because different objects have different reflection properties, then different type of light may fall on those objects, right? Means one light may come from the source directly, then that may fall on that object, then one more light ray come from striking on one object, from that object some light ray is deflected, then that might have fallen on that particular object. Right? That's why these are the factors we have to consider. The light source, which light has fallen, right? Then what the object surface, what type of object you are using, because there are the shiny surface, there are rough surface, right? These different surfaces have different reflection properties, right? The factors determine the lighting effects are, that's why the factors determine the lighting effects are the light source parameters. Again, light source parameters are position, right? Again, position also matters. If light source is backside, you are seeing that is what happened from front, and again that is the light is effectively different. Light source and UR are at the same side, then again that the object will reflect differently, right? Electromagnetic spectrum, then shape of the light, right? Again, point source, the distributed source, again different shape of lights are there. Lamp and tube light are different, right? Your table lamp and tube light will produce different type of lights, right? That's why these all factors will affect when you are considering light source, right? Then definitely, as I told, light source also matters when you are calculating, when you are viewing any object in your eye, right? Then next is surface parameter. Again, as I told, we have to consider surface properties. In order surface parameters, position means how that is orientation, how that surface is aligned, made angle with real light rod, right? There is a position. Then reflection properties. Reflection properties means mirror has different reflection, prism has different reflection properties. Then like this means shiny surface, rough surface, they have different reflection properties. Means light reflected is not same in all type of objects, right? Position of nearby surfaces. Again, position of nearby surfaces, because some light may fall on that object, then that object may reflect some light. That reflected light may fall on this object, right? Again, that light may enter into your eye, right? That's why position of nearby objects all we have to consider whenever we are calculating the lighting effects or illumination models, right? The eye, again, one more is eye. Camera parameters, again this one also matters. From which angle you are viewing that one, right? From which side you are viewing. That's why if light is back side, you are looking from front side, right? Again, that time object looks differently. Light and your camera are at the same side, then again at that time object is same, but the light effect on that object is different, right? Then that's the camera position, sensor spectrum sensitivities, and what type of sensors you are viewing. This means eye, some eyes are blurred, in some eyes may see nearby objects, some eyes may see far away objects. That is again sensor spectrum sensitivity. These are the parameters we have to consider whenever we are rendering any object in OpenGL, right? For all these we have to consider whenever we are rendering. Then for setting these all parameters, we have APIs in OpenGL. First we have to set, because as I told, when our real light camera is taking a picture like a real object, when our real light means real cameras are taking if you take any object image in real camera, if you see that film picture, then you will feel that it is a real object, right? When that camera is doing the same thing, if you want to generate through your OpenGL, then those facilities must be there in OpenGL. It will definitely lose the quality, right? That's why OpenGL supports APIs for all these, setting all these parameters, right? Then type of illumination models, there are different types of illumination models. One is ambient illumination, one is diffuse reflection illumination, then one more is specular reflection illumination. Ambient illumination is nothing but assume there is some non-directional light in the environment. That is what a background light means. In this example is this room light. There is no light now. Whatever you are doing right now, there is no light ray from any individual source, right? Whatever light has entered in this room, definitely that light is from sun, but that rays are not directly from the sun to into this room. They are falling on the ground, right? That sunlight might have fallen on the ground, then ground has reflected some light, then that reflected light might have struck the wall, then from that wall that light may be entering into our eye, right? This is what ambient light, that is what a background light means. Background light is not always comes from the source. Background light is false, means it is a reflection, recursive means reflection of light on different surfaces. right? Again that reflected light may fall in that wall, right? From wall again it may fall in other wall, again from other wall like this. After that it may be entering into your eye. This is what ambient light. That is what normally we call it as a background light, right? By default, OpenGL uses this. OpenGL uses ambient light as a lighting effect, right? By default, option in OpenGL is ambient light. That is what. Assume there is some non-directional light. There is no direction at all. One light may fall on that left side wall. One again that may reflect from left side wall to right side wall. Again right side wall may reflect to front wall. Then front wall again may reflect to back wall. Then after so many reflections, that light will enter into your eye. Right? That is what ambient light. That ambient illumination. Right? Then diffuse reflection. Diffuser laboratory surfaces are rough or grainy like clay or soil fabric. Right? These are clay, soil, fabric. These are reflected lights is called diffuse light. Means once light falls, direct sunlight means again the light falls from the source, directly from the source. Light falls directly from the source, then that reflection of light in all direction is equal. Always light reflects in all the direction equal amount. Intensity of the reflected light is in all the direction is equal. That's what diffuse light. Right? That's why if you see that object from any side, you will not feel there is a difference in that object. If you see such objects from any side, then you will not feel this side is different, that side is different, right? Because light is reflected in all directions with equal intensity. Right? That is what diffuse reflection or diffuse illumination model, right? Like normally solid objects, right? If you take your paper, right? If any solid object, wall, all those things. Once light source directly from source, I am talking about directly from source, not ambient light. If it falls directly from the source and any of the object, then if you change your position also, if you see from left side or if you see from right side or if you see from front or back side, the object light intensity is same, right? That's what diffuse light means. Reflected light reflects in all directions with equal amount, right? That's what diffuse illumination, right? Then next is specular reflection. Model shiny and glossy surface like metal, plastic, etc. with highlights. Means if you take your silver glass, if I think most of you observed that some part of that silver surface is shining, then other portion may not be shining. Other portion may be some lighter, brightness may be less, right? In some of the portion you are seeing entire face of that, you may be seeing entire face of that surface, but whatever you are seeing surface, the entire surface is not with the same intensity. Reflected light is not same. Some portion may be shiny, other portion may be some brightness may be less. That is what shiny surface, right? Normally if you see the steel rod and other things, definitely if you hold, then some portion is shiny, some portion is not shiny, right? This is what specular light means. Whatever reflected light is there, reflected light will not reflect with equal intensity in all directions. Reflected light will not reflect with equal intensity in all directions. Whereas in some direction it will reflect with high intensity, in other direction it may reflect with lesser intensity. That is what specular light. Objects normally plastic and metals, right? Metal devices like this. Definitely if you see, some part is shiny, some part may not be shiny. Right? These are different type of illumination models. All illumination models can be implemented in OpenGL. For using these all different type of illumination model in OpenGL, we have the APIs. APIs will be there to set these type means to calculate the intensity of light on the objects, right? We have the APIs. Then we will go to program. Before going to program, I will explain with output. I will come from the output side with what we have done in this program. This is the output you will get as per your object, the objective. That is the definition of program. You have to consider object property, you have to consider lighting property, right? You have to draw a teapot. I think you observe this, right? The properties of object, wall, right? Wall, light may fall on wall, then from wall it may reflect on the table, then teapot. You see that there are some portion of teapot is shining. Some portion of teapot is shining, but that is since we have considered steel or metal teapot. Once you take a metal teapot, then as I told, only entire all teapot will not shine. In again in which direction, again direction also matters. Whenever you are seeing a shiny object, direction also matters. In which direction you are seeing, if the reflection is at the same direction, that part will be shiny, right? That part will be shiny. That's why those assumptions we have to consider here. Means from which side you are seeing, only that part of the object must shine, right? Other part normally will not shine. That's why in this case we are seeing that object from this side. Means we are standing somewhere here. Means somewhere here. Means in front of this corner, exactly opposite to this corner, somewhere here. Again away from that table, away from this room, we are seeing that object. That's why this part you see here there is a shiny. There is a shiny part. Means our camera is somewhere here, right? Then that is regarding camera setting, right? I will tell why I am telling this one. Where we have done that camera setting in program. Then we have drawn this object, then table, then teapot. Means object in the sense, here there are three ones. This one. This is one cube-like structure we have drawn. Two sides are not drawn. Only we have drawn three sides. Means actually for three sides we have not drawn. Means the top we have not drawn. This side we have not drawn. This side we have not drawn. Means one open cube architecture we have drawn. We have to draw wall. This we have drawn like means how we have drawn again cube we have drawn one surface separately. This surface I will draw, then next this surface I will draw, this surface. Again we will tell the order, in which order we have drawn. Again order also matters here, right? I will tell the order. Then afterwards we have drawn the table. In how we have drawn table, entire table drawing is not possible because there is no primitives available to draw a cube, to draw a table. There is a primitive available is the direct primitive available for drawing a teapot, as I told in theory, right? There is a direct primitive available, OpenGL primitives available to draw a teapot, but there is no direct primitives available in OpenGL to draw a cube, to draw a table. Then we have to use the other whatever primitives are available. By using those primitives we have to draw those objects, right? How we have drawn? Then we have drawn a table, this surface, then we have drawn legs individually, right? This is the normally drawing. Then how we have drawn, right? Because every point is important here. In this case, origin is this side, this corner bottom. This corner bottom is origin actually. We have taken origin of our image, this picture origin is this corner bottom somewhere here. It is not visible. That side, table that side, right? That is origin. Then this is x-axis. This is x-axis. If hold right hand, the left hand thumb, then this is x, this is z, this is y. This is y. This is x. This is anyway. This is x. This is z. This is y. This is y. Right. This is y. Means nothing but this is y. X, z. Right. Z towards this is positive. Z at this side. This way z is negative. Again, x is towards this positive. X is negative this side. Right. Again, x is y is normally positive this side. Means since origin is here, I am telling origin is here. That's why x is positive this side. Then back side x is negative. Then z is positive this side. Then back side of this one z is negative. Then y is negative below. Then y is positive above side. Right. That's why this is origin. Right. Then our camera is somewhere here. Our camera is in somewhere here exactly. Not exactly at the bottom. Some above the wall somewhere here in front of z axis, in front of z, somewhere here we are standing, right? Then how we will draw? First we will draw this one. Right? How we have drawn? We will from this we will move exactly center to this. We will come to from this. I will move in x direction exactly center. In y direction I will be here only because I am moving in this plane. I will come to in this y. Then in z direction I will come somewhere exactly middle. Then from that middle, then I will draw a cube. I will draw one cube with some thickness, with some height and some width. Some thickness, some width and some height. Then I will rotate this side and rotate about z axis this. Then automatically this wall, because this is z axis. If you rotate about z, then that will be this wall you are constructing. Then after means we have constructed first this one, right? Then afterwards again I will come back to again origin here, again I will go back to origin, again from origin, again I will come at center, then again I will do this with some thickness, some width, some height, right? Then afterwards again I will go back to origin, again because in this case we have used the push and pop matrix. In this case we have used the push and pop matrix, that's why I am telling, again I will go back here, I will come back here, right? Again I will go back here, then again I will some distance I will come to x, right? Then I will move in, again I will be in y, I will be in same y I will not change, I will come some distance in the z, then I will draw one more cube, then I will rotate about x axis, and rotate about x axis. If I rotate about x axis, it will come here, then this will be drawn, this will be drawn, means this is x, this is x. If you rotate about x like this, if you rotate, this is plane is here, if you rotate like this, then this will go and stand here, right? Again I have drawn that plane here, I have rotated. You draw every plane here, you draw every plane, means whenever you are constructing anything in your home, first normally whenever you are constructing a door and all things, carpenter will construct that door on the ground, then after that he will take and it will place it in its respective, like that we have constructed everything here, then after that we have rotated about z axis, then this one, then next we have constructed this one, we are not rotated because I want exactly at the same position, mean on the wall, on this ground, I want this on the ground, that's why I will not rotate. Then again one more such plane I will construct, I will rotate about x axis, then this means I will construct here, just simply I will rotate like this, I will construct here, I will rotate like this, right, about z axis. This is z, you rotate about z axis, this is x, this is z, you rotate about z axis, this is x, you rotate about x axis, automatically these all will construct. Then again I will come back to here, again I will go back to origin, because origin, then from origin again I will come back to center of this table, I will come back to center of this table, right? I will tell here whatever theory I am telling, in program I will tell, I will come back to center of this table, from this center again I will draw only table surface, again we will draw only table surface, right? You remember the sequence how I am going, right? I will draw table surface, right? Then from table surface again I will come back to exactly center of this, somewhere here, exactly table center surface, below surface I will come back, then from below surface I will move this side, again I will move this side, right? Then I will draw this leg, we will draw this leg, again how we are drawn, I will go to exactly at the center in y, right? Then from y I will scale, then I will draw this, then afterwards again I will come back here, again I will come back here, that's why I am coming back and I am going I am using, because I use the push and pop matrix. Always you have to take one reference, from that reference we have to start moving, because everywhere we are moving, I have to come here, I have to draw, again I have to go back, I have to draw, that's why one reference I have taken here, then again I will, after drawing this, again we will come back to this position. Now again I will go back side, because back side leg is there, then I will draw that leg, right? Again we will draw that leg, then again I will come back to center of this, then after that we will come here, we will draw this leg, again we go back, because you don't know how much you have to move this side from this, that's why always you take one reference point, from that reference point you start moving right, left, front, back, whatever, right? That's why you have taken reference point of center table, exactly table center is our reference, again on the below one, not on the table, again on the below one, right? Then last I will go here, then I will draw this, then after this again I will come back here, again I will go back to origin, because we have started with the origin, again I will go back to origin. Then from origin again I will come back in some I will come some units in x, I will come some units in y, then I will come back to I will move some units in z, then with a 30-degree rotation I will draw the teapot, right? This is the regarding drawing. Before this I have set all the lighting effects, right? This is how we are going to draw. Now we will go to program, whatever I explained, same thing we have done here, right? You see here, as I told, integer main RBC or character width, then glut, initialization of a glut, create display mode, I am glut single, there is no animation, that's why we are using a single, right? Glut RGB, glut depth, again because this 3 dimension we have to remove the hidden surfaces, that's why I want to use the depth profile over, I will put the depth over. Then window size 500, glut hit window position 0, 0, then we have named that as a teapot, then a glut display function, display solid, right? We will go to display function, I will come to display solid display function here. This we have set the illumination model, right? This we have set the illumination model, right? Whenever any object you are seeing in real time, definitely there may be ambient light, there may be diffuse light, there may be specular light, right? Definitely all three type of lights combined together falls on particular object, then that whatever ray is coming, that is a group of these type of lights is entering into our eye, right? Then there is shiny matter you have to encode. Means if you are considering a specular light, then what percent of shininess that object is giving, right? There are some object 100% shining, there are some object less, their percentage of shining is less depending on the object. That's a shiny factor, right? I am using an ambient light that is 0.7 red, RGB 0.7 red color, 0.7 green, 0.7 blue, then white. This is alpha factor, right? Again diffuse light 0.5, 0.5 RGB, these are RGB color, right? Specular, then 1.1.1, then shining factor. Shining factor is 50%. I have taken only that object will whatever light falls on that, only 50% of the light will be shine, right? If you are considered specular, if you are considered specular, right? Only specular type of lights will shine, other type will not, they will not shine, right? Then material properties, then material values you have to set. Here material values, then GL front, GL ambient light, GL ambient. Then use ambient light. Means that ambient light, it is observing ambient light, it is observing diffuse light, it is observing specular light. Means on that material there is a light. If light comes, then ambient light is also coming, diffuse light is also coming, then specular light is also coming, right? These are our light, these are properties of ambient light, diffuse light, specular. Means what is the intensity, you have taken, then that light is coming here, right? Then GL power, GL means shininess, shiny factor. Then shininess, again this much portion of shining it is coming, right? This is illumination model setting. We have set the illumination model, right? Then GL light. Now lighting, we have to set the where our light is, what is the intensity of source light, where we are keeping that light, everything. Again that also while explain that what type of light you are using, the position of the light, right? Everything matters here. That's why this is we have set only property of the object, means property of the material. Here we are only set the property of the material, right? If there is a wall, then it is ambient light properties, there is diffusion, specular, shininess. If there is a teapot, table, everything, the property of all the objects in this scene are the object properties are this. Then lighting means where is my light, what is the intensity of the light, what type of light I use, where that light is positioned, right? That's why light intensity, I have taken a light intensity, red color, green color, blue color with the right intensity, this much intensity, light is coming from the light source. Then position, where that light source is there, the light source is at x-axis 2, at x-axis it is 2, at y-axis at a 6 unit, means in x direction it is this side at a 2 unit, on y direction it is somewhere at a 6 unit, and z direction there is no change. On z value it is there on z, means somewhere here z there is no change, exactly somewhere here, right? That is means to position light is at position that in 2 units at x, 6 units at y, 6 units at y, light position 6 units, then 3 units, then this is alpha factor, right? This is what light. Then light effect, that is light position. Then you can use up to 8 lights, up to different 8 lights, that is a GL light 8 0 up to GL light 7. This is GL constant light effect. Then GL light 0, GL position, then use the position, then GL light position. It will use this position, right? In z direction 3 units, x direction 2 units, y direction 6 units, z direction 3 units, right? Then this is, then near value is 0, right? This is what light position. Then light intensity, this is light intensity. Here we are assigning the values, here these are the OpenGL APIs, these will set, right? Here we are assigning the values, these are the OpenGL APIs, these will make effect of these values on those objects, right? What we have done, this type of value we have selected, then these will be affected by these APIs. Again these values are selected for light position, light intensity, then these APIs will make effect of these values on these light and light, diffuse light and position, right? Then next display. Now GL matrix में GL projection. Now till now what we have done, we have set only light property and object property. Till now we are set only light property and object property. Whatever object now onwards we will draw with that property, that object, if it is shiny, then it will shine. If it is not shiny, it will not shine, depending on what type of object you are doing. If it is a wall will not shine normally. Wall will not shine normally. If it is a steel-like surface or metal-like surface, definitely metal-like surface will shine. Right? That's why whatever type of object you are doing, depending on those, they will reflect the light. Right? That we have done. Then GL model projection, load identity, it will clear the projection. Then double with window height 1.0. Window height 1.0 means window height only range is 1, means -1 to +1, that is window height. In that range only we are drawing that window, right? Then GL ortho, then the aspect ratio, window height into aspect ratio, window height into aspect ratio. This is the left, right, bottom, top, Z near, Z far, right? Z near, Z far, right? This is aspect ratio, means 640 pixels width, height, then 480 width, right? This we have taken, that's why we have directly values we have taken here, because we have taken 640 by 480, 645, 480, right? 645, 480 we have taken, that is the window. Left X, right X, bottom Y, top Y, Z near, Z far, we have set here GLU ortho. Then GL matrix, GL model U, load identity matrix will clear the previously used model U, right? Then look at, as I to look at means where we are setting our camera, where we are looking, how we are set the camera. Means user is standing 2.3 units in X direction, 1.3 units in Y direction, then 2.0 in Z direction. 2.0 in Z means camera position is somewhere here. Camera position is somewhere here, right? Camera position means camera is somewhere here, means in front, means exactly opposite to this corner. Exactly opposite to this corner, but not at the bottom, not at the ground level. Above the ground level, somewhere here you are standing. In between, not exactly between, but not on the ground, not on the middle, somewhere in front of this corner, exactly in front of this corner you are standing. That's why this you are seeing that this is shining, this part is shining, right? Then that we are set. Then look at where you are looking. You are looking at x0, y.25, z0. Means where is your target point? Where is your target point on that scene? Right? Yesterday I have to look at. Then the orientation of the camera. Orientation camera x0 means look up vector. You are setting look up vector of camera. Right? x0, y1, z0 means exactly your camera you hold. You are not tilted camera, normal camera. What is the property? Means if it is a horizontal camera, you have held horizontally. Right? You are not tilted that camera. Right? This is what look at. This is what look at. Right? Then GL clear color buffer, GL depth buffer. You clear all the previous content of these two buffers because I want these two buffers. Right? Then the other tool push matrix. GL push matrix. GL push matrix. Then I will push the matrix. Wherever I was there, I will push this one. 2.3, 1.0, 1.3, 2.0, that value I will push, right? That value I will push. Then GL push matrix. That value means I have pushed means previous values, whatever values there is, I will push it that one. Nothing but I have pushed these values. Right? Wherever means camera, wherever I set the camera, that values we have pushed here. Right? Then GL push, then GL rotated. GL rotated as I told, I am drawing a wall here. I will draw a wall here. Then I will rotate 90 degree about Z axis. I will draw here. Simply I will rotate that wall. Then that wall will come and stand here. Right? That we have done. How we have done? You see here. Rotate 90 degree rotation. 2D rotation. This is a 2D rotation. 3D rotation. API available in OpenGL, that is GL rotated. This will tell angle. First value will tell X. Next value will tell Y. Then next will tell Z. If the X, Y, Z, if respective value is 1, then you are rotating about that axis. Right? This is X. This is Y. This is Z. Right? Right? We have drawn this one. Means I will draw at bottom, at ground level, then I will just simply rotate, right, with a wall thickness 0.4, that is here. I'll call this wall. Here wall, it is not what it is doing. Again push GL push matrix, whatever original values are there, you push that one, right? Then translate 0.5, you come in x direction some value, then come y direction 0.5, in z direction 0.5 means center, then you will come to center, then there you will scale, means it will increase the width, height, width and thickness. It will reduce the thickness because 0.5 means it will go above, but I want only thickness is less here. Thickness, y is this, y is thickness of this is y, right? This is height, width, right? Then after drawing, then I'll rotate 90 degrees, like this will happen, right? That we have done. Then pop, again go to origin, again go back to origin position, right? Again go back to origin position, then you draw wall. Where you are drawing wall, again which wall we are drawing now, as I told in a sequence, this wall, means again come here, because we have pushed here, we have pushed these values, I will come back to this position only, then I will draw this wall. That's why I have not rotated, because I am drawing at a ground, I want at a ground. Means I have drawn at a ground, I kept at that wall, that's why I have not rotated. This wall I will draw. Now I have to draw this wall, right? I have to draw this wall. That's why again I will come back to here, again I will come back to pop, right? Again I am there, anyway I am there only, because I have not pushed it, I have popped only there only. Then I will push that values, then I will rotate, means rotate. How it will happen? Actually I will draw, then afterwards I will rotate. Then again what? Same thing, I will come to this, right? I will draw that wall, then I will rotate 90 degree. About x-axis, you see about x-axis I rotated here. About x-axis we are rotated minus 90 degree. About x-axis, as I told, which value is set to 1, about that axis you are rotating. This is x, this is y, this is z. Since x is set to 1, nothing but you are rotating about the x-axis. Here since z is set to 1, you are rotated about z-axis. That I have told. This is z, this is z, this is x, this is y. You draw here, rotate about x, it will go here. You draw here, since this is x, you rotate about x, it will come here. Same thing we have done, right? Then here, that's why 90 degree I rotated, then I will draw. Means actually we will draw then rotate. Function while during execution it will happen in a reverse, right? Draw and rotate, right? I will rotate it. Then now this cube drawing is over. Now we have drawn a cube. Now we have to draw this table. Then afterwards Teapot, right? While explaining, I explained that sequence only, right? Now pop matrix, again pop, right? You will come down exactly middle, then push, then you will come here. Means again already you have popped here, because in this also you have popped. Then now here you will come at this. One more time if you pop, you will go to origin of this, that is the backside point. That is the backside point, you will go to backside, right? Because in wall also you have popped. After popping you will come here, then one more time if you pop, you will go backside, right? Then now you will come to that, right? Then push matrix, you push the origin, then GL translate 0.4 in x, 0 in y, 0.4 in z. GL translate 0.4 in x, 0.4 0 in y, 0.4 in z, right? Then you draw it. Means we have exactly coming center of this table, below the center of this table, not here, we are coming exactly below the center of this table. Since we have not drawn table, but just I am for your explanation purpose, I am coming in such a way that after drawing that one, that point must be below the exactly center of this table, right? Exactly here, somewhere here in the center, not center of this wall, we are center of this table surface, right? We have moved. Then up that, now I will call it table drawing. 0.6, 0.02, 0.02, 0.3 values we have passed. Then what are those values? You see here, table. That is top width, table top width, then table top thickness. Top means table top we are drawing. Top is width, top is thickness, top leg thickness, right? Leg length. These are leg thickness, leg length. Means top width, top thickness. Only now we are drawing only top of the table. Still we are not drawing. First we will draw the top of the table, then afterwards we will draw the leg. Right? That's why push matrix. I will push the below value, whatever the below value is there, I will push that one. Then GL translated 0 means in x direction I will come 0, in y direction I will come up, in y direction I will come, that is the leg length. I will coming up in y direction, I will coming up in leg direction, because in x I will be same, I want height, that's why in y I will come with the leg length, whatever leg length I have set, that is leg length I have set 0.3, I think leg length is 0.3, leg length is 0.3, because this is, you remember, this is 0.6, 0.02, 0.02, this is 0.3. I will come height, there is no change in z. I will keep as it is 0. Right? I will come at that height. Then scale top width means you increase with the width size, top thickness, width. Right? You want like this, means here this width, then thickness. Thickness of this table is only this much, that is in y direction. That's why you see here what we have done. Here top width, that is 0.6, top thickness 0.02, we have sent 0.02 alcoholic, then top width 0.6 means square. We have drawn square like top, right, with some thickness. Then blood solid with 1, right, then pop matrix, then again it will pop, again after popping where you will come, exactly will come at the below, of this, because you have pushed the value exactly center, table center, then you will come here, right. Then afterwards, till now we have drawn the table top, still we have not drawn the table legs, right. That's why double distance 0.95. Why you have taken this value means we don't want to draw the table edges exactly, table legs exactly, means the table legs should not come out of the table surface. The table legs should not come table surface outside, right. That's why to take some position inside we have taken this, right. Here what happens, if I draw somewhere here, then the leg will come outside these edges, here also leg will come outside these edges, right. We don't want, normally table legs will not be outside the top side, right. Only there are some within this surface, within these corners. That's why to adjust that we have calculated that value. Right. With that value I will adjust in wherever I want, right. That's why again a push matrix, I will push again that value, then GL translated distance, I will go in x this much distance, in x direction I will go this much distance, right. In y I will not change, then z I will change with this distance, z I will translate, means go in x direction you go with this value, y direction there is no change, then z direction you go with this distance, z direction you will go with translated, we will go with this distance, then table leg left, table leg top, table leg thickness, table leg length, right. You see here table, then what is happening here, where you have gone, as per this, where you have gone, in x direction you are moving with x distance, right. In y direction you have not moved, in z direction you have moved with some distance, nothing but you have moved here, we are moving here, we are at the ground. X direction I will come some distance this side, positive x, right. Y direction I have not, means I have not come up, still I am on this surface. In z direction I have moved some positive z, right, some positive z, then I will move here, because since we are in positive z only, we are not in negative z side, I will move here only, then I will move here only, right. I will come this, I will come here. Now my point is here, now I have to draw this leg, that's what I will do. I will go exactly at center, then I will scale with this, then I will join here. Now you see I am below the top leg, that leg, right, that leg, then table leg, we will go to table leg. What is table leg? Then push matrix, that value push, then GL translated 0 means x direction there is no change, but in y direction length by 2, what is our length, what is there in value in length, leg length is 0.3, right, that is leg length by 3 means 1.3, then length, then 0, means again there is no change, means as I told, I'll come up exactly at the middle of this leg. I'll come somewhere here, then I'll draw this leg, right? Again I will pop, I'll come back, again I will pop, I'll come back here. You see, after drawing that one, right? After I am here, table, I will pop, I'll go down at that leg only, then again once again if I come, right, I am there only, then I'll GL translate 0, 0, 0.2, minus 0.2 distance, nothing but I am going this side, this leg, I am going this side, that is minus point. I am going somewhere here. That means I am drawing backside leg. I am drawing backside. Again same thing. I will go to there. I will come middle. Then I will draw that leg. Same thing. Again I will call this table. Again it goes the length of exactly middle of them. Then it will draw that leg. Again it will pop matrix. Again it will come back. Then from there again translate -2 in x, right? 0 in y. Then 2 into distance. That is this leg. -2 in x, right? -2 in x. Suppose if this is your, if you are taken positive this side, then when you are going back side, you have to take minus, right? You have to take, means yeah, we have drawn this and I have drawn this. Now I am actually previously whatever I told wrong, I have drawn this, means no, we have drawn this first, then this first. Now we are drawing this leg, backside leg. That's why if this positive x is positive this side, then if you substitute, if you multiply with the negative, then it will go back side, right? Then that leg I will draw. Again same thing, I will go at middle, I will draw that one. Afterwards I will come here, I will draw this leg, right? One by one legs we have drawn, right? You see here. Then that leg, then again GL translate 0, 0 in -2 this. Then table leg, this we have drawn. Then pop matrix. After popping matrix, I will come exactly center of the table, right? Then afterwards, then now we have drawn walls, we have drawn 3 walls, we have drawn table. Still we have not drawn teapot. Now I am exactly below the, means after this pop, exactly we are center of the, below the center of the table. We are here. We are exactly somewhere here. Now one more pop, it will go here, because you have to remember how many push and how many pop you have done. When you are pushed, where you were, when you are popping, where you will go, right? That you have to remember, right? Then I will pop here. We have drawn table, we have drawn walls, right? Still we have not drawn teapot. That's why I will pop again. If I do, then I will go to origin, that is back corner. Then I will push again that value. Then GL translate 0.6, 0.38, 0.5. Means in this I will come 0.6 in x direction from origin, 0.38 in y direction. Some height, right? I think 0.5 in z direction, 0.5 in z direction, right? That is a +5. Then we come towards positive, right? Means I have somewhere exactly at below this teapot center. We are exactly below the teapot center, right? Then we will draw this teapot with 30-degree rotation in y direction. That's why you see that teapot is rotated with a 30-degree in y direction. This is x, this is y, this is z, and this is angle, right? I have rotated. You see, observe this one. This is rotated about y. It is not exactly this. This is not exactly parallel to z. This is not exactly parallel to z. This is not exactly parallel to z. This is about y. About y axis, it is rotated 30-degree. About y, it is rotated 30. That's why here this is towards this side. This is towards this side. That's why this is rotated. Teapot we have drawn, right? Rotated teapot we have drawn. Then that's again, as I told, there is a built-in primitive is there. To draw a teapot we have built-in primitive, but to draw a table and wall we don't have built-in primitive. There is a glut solid teapot with thickness 0.08 value. It will draw that teapot. Then pop. Again you will go back to origin, then flush. Then it will draw teapot with all effects, right? Again here, as I told, to enable lighting effects, GL enable lighting. To enable light position, GL enable light 0. The lighting effects, light positions, right? Then shading smooth shading, again different type of shadings are there. Smooth shading, GL enable depth test, then GL enable normalization. You have to normalize all values, let GL clear. Then U port 00, as I told, 640 640. U port is 640 by 450. That's why aspect ratio we have taken here 640 by 480, 640 by 480. Right, this is what the output. Right, you will look output. If you change the position of your camera and position of light, you will see shiny surface different shiny surface. Right, this is the output of this program.